Hello everyone. Suppose you have 100 Sentinel-1 data sets of a particular area or a particular coverage. So it is like, say, example, for several years, like from 2017 to 2024 or 25 or 2026 also, you are doing some studies related to the landslide or subsidence or any kind of deformation using that Sentinel-1 data. And how do we do that? Generally, what we do is we take two images of Sentinel-1 and then we process them and then we get some value and then we do two more images like that. This takes a lot of time. That means analyzing one interferogram is not enough. In this case, MintPy comes into a role. So, what is MintPy? MintPy is generally Miami InSAR time series software in Python. So this uses Python to do the processing. This is an open source tool for InSAR time series analysis. The developers are mainly focused on InSAR time series analysis, which works with output from ESA Snap, ISE, ARIA, GMT-SAR, and others. And we also need to know the purpose why we are using the MinPy. That is because we can convert hundreds of interferograms into a meaningful products. Something like for the subsidence, you can go for the velocity maps or the displacement time series or even temporal evolution and also for the quality assessment. Okay, now I'm going to explain you everything in detail. And this particular series includes the introductions of MintPy, and then we'll go for the installations of MintPy and how do we do the process and how do we compare the results also. So uh, please watch the whole series and you'll understand everything clearly. Now, why do we need MintPy? That is because we are using the single interferogram that contains noise, atmosphere, and decorrelation errors and also orbital errors. For this, uh, to remove those things and to get precise values, we are using MintPy. Now, what problems does MintPy solves? Before this, I just wanted to tell you one thing. When we are going for the regular practice, like taking two sentinel images and then creating an interferogram and then doing the processing, that will not solve the problem because in a single interferogram, it has atmospheric noise, it has temporal decorrelation, and also it has orbital errors, like I have explained here, and also some seasonal effects. So, a single interferogram may show deformation that is not real. So, the time series analysis, anytime, if you go for other softwares like Stamps or MinPy, you'll have to do the time series analysis. So, the time series analysis uses many acquisitions, like from every 12 days you'll get data, so you can take for years and then you can do the processing and then you can get signal that is free from noise. So this is where MintPy generally is used. So what problems can this solve? So it is used in detecting the landslides, it is used in monitoring the subsidence, it is used in tracking the infrastructure deformation and also analyze the volcanoes. So how is this going to happen? If you take the velocity map, if you take the velocity map, then average deformation rate can be known. If you take the time series map, then movement through the time will be known. If you take the coherence estimation, then the data quality will be known. And most importantly, the curves or the output that comes as a that comes as a curve is used for landslides, subsidence, mining, infrastructures, and volcanoes. So here you already know about the Sentinel-1, and then we are processing it in the snap and we are getting the interferogram. But when you have a bulk number of data, you can go for the uh, Sentinel data with the MintPy. So this is where the total processing goes. And like I explained, the outputs are velocity maps, displacement time series, quality assessment, and deformation curves. And now we can do the same processing in other softwares also. The alternatives are LIC SBAS. It is easy to access the Elixir products. So the advantages are it is good for regional studies and it has less pre-processing efforts. But there are limitations also for this one. It is mainly tied to only the Elixir ecosystem and it is less flexible. Mostly it is good for the beginners and also it is for rapid analysis, just like an overview, not complete in detail. And the other alternative, we have stamps, and this is widely used as a persistence interferometric software, but this has a requirement for MATLAB. The learning curves are way steeper. That means you'll have a lesser um, probabilities for error, and this is very good for urban subsidence and also for the persistent scatter studies. MATLAB dependencies are a little hard to available. You have to purchase the MATLAB, and the workflow is also very complex. These are the limitations for STAMP. And the other alternatives are Pirate and Giant. These are other time series solutions. We can use this one also, but these are not used more in these days. And coming to the Pirate, it is an Australian geoscience project, and it is a good open source software, but small users community. Now, why do we choose MintPy among all these softwares? MintPy is generally Python-based software, and it is active development. And large users are using this. So, if you have any kind of a question or a discussion, you can go into that community and then you can find out the solutions. And especially the visualization is also very high because when you go for a particular region to do the study, the information what you get through MintPy is something very detailed. So you can go for that MintPy, and it is supporting the SBAS, and the integration is also very easy. In the coming videos, I will also show you how to install and then use it. The interface will be very easy. All you have to know is the proper Python script. That's it. And if you have a script, you can change the coordinates or you can change the other details, and then you can use it for yours. So the reason why I choose MintPy is because for landslide monitoring and also for the ground deformation studies, I chose MintPy because it is open source and it is actively maintained and it is most importantly Python based. So if you are a beginner, you can go for MintPy. If you are focusing on regional monitoring, you can go for like SBAS. If you are focusing on urban persistent interferometric regions, then you can go for stamps. And if you have a MATLAB workflow, you can go for stamps. And mostly, if you are really looking for open source workflow, you can go for MintPy. And in the next video, we'll install MintPy and understand the files required before running our first time series analysis. Okay, so please do follow this series and please do comment if you have any other queries. Thank you for watching.